Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Ladies and gentlemen, welcome back to another video or to another live stream. And hold on a second, I just realized that my desk is not very well aligned. Hold on a second. Hopefully I won't break anything. Okay, great. Alright. Okay, alright. So let me see, is everything good now? Are we streaming yet? Cool. Cool. Alright, so let me share the video or the stream with my Discord server. Please join my Discord server. You can find the link in the description. Alright, let's see. Come on, bro. Why this is super slow? Okay. Alright. Come on, bro. Okay, I think we're all good at this point. Everything is good. The mic is on, camera is on. Alright, cool. Yep, everything seems good. So I think we're ready to start recording. So today I'm gonna be doing something a little bit more different. So if you don't know, I actually have most of my experience is with Luau, Roblox Luau. And Luau, by the way, Luau is just like, first of all, it was developed by Roblox for Roblox, but then it got open sourced. So right now it's actually open source. It's written in C++ from scratch. And of course, it's built. At first it was very similar to Luau, but right now it keeps on changing, like adding type checking, sandboxing, etc, which is quite nice. But either way, if you go, like, you could either follow with this tutorial, you could either follow this tutorial with, let's say, Roblox, coding in Roblox, or like what we're gonna do today in this video, we're gonna be using VS Code with the standalone compiler or the standalone interpreter. So yeah, so basically you could go to this page right here. Right, though of course the module that we're gonna develop today, I'm gonna publish it when we're done with it. We're gonna publish it in GitHub so we can all use it and all help implement it further. So you can find a lot more information in the description. So, okay. So in the releases here, you could go here, get the latest release depending on your, if you're on Windows, Ubuntu, or Mac OS. And then you could basically add it to the path. There you go. It's right here. So you're gonna get 3 executables: Luau and Luau analyze and Luau compile. So compile, you could use it to compile the Luau code into bytecode, Luau bytecode, and like for the Luau VM essentially. And Luau analyze, you could use it for like linting essentially, and error checking. And Luau, you could use it to run Luau scripts. Though of course you may want to actually extract this and add it to the path. Add it to the environment path, variables, and go to path. Not here actually. Well, you could do either one of these, either the user or the system, doesn't matter. As you can see here, I have just added that to my path. And now if I actually run a command line, terminal, Now I could basically use Luau right now. So there you go. Now I get a REPL, for example, print, oopsies, 1 plus 1. Oops. Okay, hold on. What's going on here? Well, come on, really? This is weird. Oh, okay, there you go. Okay. There you go. So as you can see, you get a REPL like this. But anyway, so I'm gonna be using VS Code, and I'm gonna be using one extension that would do the linting and error checking for me. And it's called I think, yeah, there you go, Luau language server, Luau language server. Though I have indeed, if I go to my settings here, this is my preferences, using font family, pheromone code and stuff like that. Anyways, you could check it out. But what's important here is that I have Luau LSP types Roblox. I disabled those because I'm not gonna be doing Roblox stuff here. Just gonna be Luau, standalone Luau, so we can work either with Roblox or standalone Luau basically. But anyways, so Luau LSP inlay hints. I also enabled all the inlay hints because I love inlay hints. You're gonna check them up soon. But anyways, so right now I'm gonna create a little new folder. So mkdir. Let's see, Luau maybe. Fine. Or like maybe Luau. Okay. All right. And then I'm just gonna run code or VS Code in that folder. And I'm gonna configure the chat. Hold on a second. Right. Oh yeah, it's already configured here. Cool. Is the live good? Can anyone please confirm? Seems good to me. Anyways, so now I'm just gonna do this, and there you go. All right, cool. So let's create a main.lua file. Okay. Great. And I'm gonna create a module called iterators, or like iterator.lua. Okay, cool. Now we're gonna say, first of all, let's start with the boilerplate of OOP type checking in Luau. So, okay, let's just go to this article right here, or this post in the dev forum. Here's the link, and here, there you go. So you basically say, you don't really have to remember this, it doesn't really matter, but basically you say this, just copy this up, and essentially, oops, and copy this one, and this one, and yeah, that's it. So now I'm just gonna rename this car to iterator. I've just typed there F2 to refactor it, and there you go. So now we have our iterator. Now here, this is what the iterator table would contain. In our case, we want to basically store a function. So we're gonna say, I'm gonna call it iter, and it's basically gonna take no parameters. This is basically my next, actually. This is my next method, basically. And essentially here it's just gonna give back either a t or nil. So either some generic t value, some type t, whatever that type is it a number or whatever, who cares. Great. Now since I've done that, I forgot to change this one. iterator. Okay, and also I don't really like to do it this way. Just remove this and just gonna do it this way, and yeah, pretty cool. So now, as you can see, it's gonna tell me that type error the parameter list is required, because right now I added a generic t to myself, so we gotta add it here. Of course, the type checking in Luau is still very, very limited, but hopefully would be improved in the future. But for now, it's fine. So there you go, some generic t, and here's some generic t. Okay, cool. So here we're basically gonna take a next function, and which would basically be this way. Yeah, like this. So, and here what we're gonna say is next is equal to next, just like that. Now what's next? All right, so here the AI is trying to help us here, but let's just start with some other constructors too. Let's say the iter, maybe I'm gonna call it, or let's call it iterate actually. Fine. And or honestly fine, just go with iter. Yeah. And here let's get a table, some sort of a table. So here what we're gonna say is so it's gonna take some k and v, right? So we're gonna need some k. In fact, I'm not gonna call it iter, I'm gonna call it values. Okay, values. Great. And honestly, I'm gonna, yeah, fine, anyways. And here, what we're gonna return is an iterator of values. Key. And honestly, instead of t, let's just call it item. Fine. Item. Cool. So here, yeah, this is gonna be the key and this is gonna be the value. Great. So now we gotta return an iterator new. Yeah. No, that's not enough. So next function basically takes a table and it takes the last key, and it basically gives you the next entry in the table from that key. So we gotta indeed store the key, and the key would basically be nil, and it would be key or nil basically, right? And here we're gonna say key value. Right here, let's just say local value, and there you go. Cool. Now what's next? So how we can use this basically, hold on, I forgot to actually use this. In fact, key, let's call this iterable actually. Fine. Okay, key. So that should be good enough. Now let's actually create, well, first of all, let's require this module. So iterator is equal to require iterator. Okay. Yeah, I forgot a little thing. We gotta return iterator here. And there you go. Okay, cool. So now let's just say local iterable is equal to a table. Yeah, fine. Let's say ABC, blah, blah, blah. Now what we could essentially do is for x in, or like for value in iterator, the values iterable do. And there is a bug here in the type checking stuff, in error handling. It's saying type error cannot call none. Well, actually that's quite true, but for now let's just say, for now at least, for now let's just say dot next. Okay, now if we say now let's actually compile this or run this. Luau main dot Luau. Okay, so as you can see, we got ooh, interesting. We got 132. Yeah, it's correct. It's correct. We're getting the values, but of course, since this is the hash part of the table, it's of course not ordered, so it can be in any order, whatever. But of course, if it was, and in fact, we don't really need to do it here. I mean, you could just do it here, in fact, if you want to. And we can even remove this, these parentheses there. And there you go, iterator.values, and this would just still work just as fine. But if you, it would also of course work with a regular table, so the array part of a table. So dot next, as you can see, 1 2 3. Great. Great. Now let's say I don't want to use dot next. I just want like to give the iterator to the for loop and it would just work, you know, work TM. So so how we can do this? Well, we're gonna of course use the meta table, the meta method call. So how are we gonna do this? Well, let's see. Okay, let's do it here, I guess. Not really. Let's do it here. Okay, so function iterator dot, well, yeah, call, fine. Now the problem currently with well, it's not really a problem, but just a problem in ergonomics, kind of. It's not very ergonomic, is the fact that you cannot use a colon with type checking anymore, with type checking and generics, you know. So to actually specify the generics, you have to only use the dot operator, like the dot stuff, right? So you basically cannot use the colon. So, but anyways, so here what we're gonna do, well, just dot next here, and self item, oh, self, shouldn't we use iterator instead? Can I use self here? No, I cannot. I don't think this is correct. It's probably iterator, you know. So self.next here, and now we don't need that anymore. So if we run this, it would just work fine without dot next here, right? Of course, if you value performance, you probably just wanna go with the next directly so you can avoid the meta method. But anyways, right. So this is kind of annoying, this false positive here. Let's just, but this actually works like this. If you do it like this, it works just fine. It doesn't complain. Now the nice thing about type checking is that sometimes it actually caught some errors, some intentional errors. And the other thing is the fact that you can see with the type, like you can infer the types, and hopefully in the future it can even hopefully use those types to even go ahead and do, yeah, for performance reasons, right, to optimize it even further. And actually I forgot one thing. We gotta make sure to add strict here, just so it tells us if there's any problem with type checking that we have missed. And yeah, so now as you can see, if I hover over this iter, as you can see, it tells me that it's it gives back a number, which is quite true for this one. All right, let's go to the next one now. Let's actually implement now keys function keys, and for that, and just instead of value, it's just gonna return key, and we don't need the value anymore actually. And since we're not using it, let's just prefix it with an underscore there. And now instead of iterator value, the type of the value, we're gonna return an iterator with the type of key, which is great. Now if we say keys instead, now it would actually go ahead and loop through the keys of the table. But of course this would be the same because the keys and the values in this case are the same. But you can imagine, like, if we have hello world blah blah blah, if we'd say this, the keys is 1 2, the values is hello world. Okay, great. All right, what's next? The other thing that I may want to do, I'm not sure yet honestly about this one, but for a little bit of an optimization, it would be nice if we can optimize collecting iterators into tables. So what I mean by that is when you have a table, you know, like, hold on, when you have some, well, honestly, let's keep it until we implement another method called collect. And of course, all of this is from my favorite programming language called Rust. It's a low-level system programming language. I really love it. So Rust iterator. There you go. So I'm basically kind of replicating this essentially. So here, as you can see, type item, that's basically our generic type here, though of course here it's an associate type here, but whatever. Here our next function, so it's an option, and basically option is just this in our case, self item blah blah, right? And there you go. So it would just return the items, otherwise it would return nil in our case. But the nice thing about this is that it have a size hint. Yeah, there you go. So size hint. Now this is what's interesting. I'm not sure if I can actually implement this just yet, but it would be interesting if I can. So returns the bounds on the remaining length of the iterator. So basically this could give you how much items are possibly left, just a hint of course. And what this could be used for, it could be used for, let's see. Yeah, there you go. It's primarily intended to be used for optimizations such as reserving space for the elements of the iterator, but must not be trusted to omit bound checks in safe code, and correct implementation size hint should not lead to memory safety violations. So we could use this hint to basically pre-allocate the table when we want to, let's say, collect some iterator into a table. Okay, but we're gonna go into more details on that later on, but let me see how I can possibly do this. Okay, so what if we say minimum size hint and maximum size hint? Or actually, can we do this though? Can we do this? Hold on. Size hint. So it would basically be a lazy, of course, it would be function. And hopefully it would return a tuple. I'm not sure if that's possible in Luau. Yeah, it seems like it, which is great. Number. So as you can see, the maximum is actually optional. So let's make that optional. And the other thing is that this size hint is not really required. So what we're gonna do, we're gonna make this function optional, or this field, size hint field, optional. Great. So now, for example, new here, well, we could indeed maybe pass in some size hint function here. In fact, yeah, that's exactly what we're gonna do here. And basically say, ooh, let's go with the conventions of Roblox. And let's just go with size hints like this. Great. Cool. And as you can see, I already inferred it, but let's just keep it explicit. Great. So that's cool. Great. So now what we could do. So for example here, keys. Well, if we know the length of the table, then we could use it in our size hints, basically. The problem that I see here though is the fact that tables doesn't necessarily have a good length. Like, let me see one thing. So let's say the length of some table 1, 2, 3, you know, so 3, right? There's no problem there. The problem arises though when you have, hold on, oops, it cannot, okay. The problem is when you have something like, let's say pi is equal to 3.14, 2h, or something like that, right? So here, as you can see, the length of a hash table is 0. So how are we gonna fix that? I wonder if this would work. Let's see. No, it doesn't work either. So we need some way to actually get the length of a table, hash table. And I haven't worked with Luau for a long time now, so I'm not entirely sure. I mean, of course, you could always go ahead and just loop through all the table and count the table length, but if we can avoid that, that would be nice. I'm not sure if there's anything for that. Table count. Roblox hash table count. Yeah, dictionary, they call it dictionary, so yeah, so dictionary, fine. Let's see if there's anything interesting. Yeah, pretty much that's the only, yeah, you just gotta iterate through the whole thing, which is sad. Yeah, there's a lot of things that could be improved in Luau, hopefully. I wish I was a developer there, but anyways. Because a lot of things could be implemented very efficiently natively. So, but anyways. Yeah, pretty much I don't really see any better way of doing it. We just gotta iterate through the whole thing, right? So how are we gonna do that? Well. So let's calculate the count here. So local items count is equal to 0. Now we're just gonna look through the iterable, our table, and I'm just gonna add items count. Great. And now what we could do is, now we have implemented the next function. Now let's implement the size hint function. and let's just return, oh, well, the minimum and maximum. Okay, well, for the minimum and maximum both will be items count, I believe. Yeah, probably. So, but of course now every time we iterate we gotta basically say items count minus equal 1. Yeah, so let's try this out, I guess. Let's see, can you print iterator.size hint? Attempt to call nil value. Yes, we have implemented it in keys. Well, let's go with val. Hold on, what? Yeah, let's go with keys. Fine. There you go. So it's telling us 1 1 0 0. So that's correct, I think. That's correct. Yeah, there you go. 2 1 0. So you're gonna see later on why we're gonna need this size hint. It would be an interesting optimization, little optimization, but anyways. All right, great. So now we have implemented that size hint. Now let's implement the other size hint. And basically the same exact thing, but let's just create a function just to keep things simple. Though of course, since we're using a scripting language, not a programming, like not a compiled programming language, every function call matters, but I honestly don't care. I value readability more than inline function calls. So let's just say get table size, essentially. Yeah. Yep. And now what we're gonna do, well, well, this is basically gotta be some table. Does this work fine? No, I don't think. Well, any, any get table size. I'm not sure, like, hold on a second. I'd like to stick to the Roblox conventions if possible, just to keep me sane. All right. So what we have here, we have a local function. So what they name local functions? Camel case, I think. All right, my coffee is done. All right, cool. Well, I think it's camel case, basically. So this is correct, camel case. So now instead of this, I could just say get table size and iterable. And it's fine, just iterable here, iterable here. And in fact, you don't need pairs anymore in Luau. Yeah, you don't need pairs anymore, so that's good. That's basically it. So now what? Ooh, shadow is a global variable. What? Cannot be converted into any. Yes, I see. Now that seems local shadow. Shadow is a global variable used at line 52. 52? Oh yeah, I see. Good catch. And there you go. Great. So that seems to be good to me. Great. So now what? Okay, seems good to me. Yeah, I wanted to use that items. Yeah, I've already used it at this point. Yeah, great. Great. So, oh yeah, I forgot. Hold on. Probably should make this into its own function or something. Anyways, so this should be good to go. What happened? Yeah, because we're not printing anything. But anyways, so now let's implement some, let's say, collect function. And now you're gonna see why we're gonna need such a size hint, or why it's gonna be useful. Of course, it doesn't necessarily tells you like the exact value, or like it doesn't have to. It's just a hint. And what we're gonna use that hint for is, well, let's see, item, self here. And here we're gonna give it a table T. Correct or no? Unknown type. Oh yeah, item. Fabricio Vivanzo, welcome to the live stream. When I saw cinematic with the plugin code to attack cutscene, did not play the cinematic. Also, I touched the plugin, did not start. Yeah, I really wanna remake that plugin. It's pretty much the most popular plugin to date in Roblox, so and I made it in 2020, I think, or so. Like, it's the only plugin. But like every time I try to recreate it, I just really, every time I get a new idea, so I'm not entirely sure yet how I'm gonna go, because I don't want to do the same thing again. I want to really improve it much more, make it more flexible, make it more reliable, more robust. Hold on, cutscene. There you go. Okay, so it's pretty much the most popular. And they got plus 1,000 votes, 13 reviews. What? 3,000 stars. Interesting. 86% likes. So I created it in 2020, and updated 2022. Pretty much. And there's also this other plugin right here, but I don't think a lot of people know about this one. This is basically, I made it as a utility for this one. It basically helps you move the camera, and it also gives you a grid so you can make some good captures and some red ball and stuff. Anyways, whatever. But yeah, I'd like to create it soon. I'm just not sure exactly yet how I'm gonna go about that. And the thing is, here we go, I'm creating some modules right now so I could use them in the future when it comes to Roblox or Luau in general. So this module, for example, that I'm creating right now, I'm gonna use it a lot because I just hate like Roblox or like Luau loops everywhere. I don't know. I just love functional style like that. And also using type checking, so, but anyways. So yeah, local result. Okay, so here's the deal. So we gotta basically create a table to hold all of those items. So what should I call it? Let's say results, or yeah, fine, results. And now the thing is, instead of doing this, what I could do actually is say table.create Because the thing is, if I do it this way, let me just show you. If I do it this way, and then I basically go through all the stuff. I'm just gonna use .iter here, I think. .next. And then insert every item from the iterator into the result table. And then we're gonna return the result table. So this is fine, but it's not very efficient. Because every time we insert, we may reallocate the table, you know, which is super slow. So what we could do instead is table.create, okay? And here we can give it like the count, how much items there will be in the table, if we know, of course. So the count here would be self.sizeInt, but well, if we find the size hint though, so and because it's optional, okay, there's a lot of stuff going on here, but let's just say capacity, right? And let's say local capacity 0. And now if self.sizeInt, then local minimum and local maximum. So self.sizeInt, then capacity is equal to max or min. Yeah, I think that's fine. Yeah, that's fine. So basically, if there is a maximum, then we're gonna allocate that. Otherwise, we're gonna go with the minimum. Yeah, that's good. Yeah, seems fine. So that's great. So now, let's see. Can we print the capacity? Hold on. Okay. Now let's do this. Let's say values here. For value in values, do print value. This is what you get. Now let's try collect instead. And honestly, I forgot one little thing. Let's actually call these like this. Yeah, let's go with that one. So that should be good. Now this basically should go ahead, consume the iterator, and give me back a table. Now you can notice here, since the table or like the iterator have a size hint of 2 already, since they have been created from a table, what happens is that instead of like, basically we pre-allocate the table from the start using that size hint, as you can see, which is pretty cool. So we create the table at the start, and yeah, there you go. Nice, pretty cool. That's nice. So now let's do something more interesting, I think. I'd like to create some other constructor. And I'm not sure, honestly, what name I would like to give this constructor. Not really. Yes, in Rust you do a range, right? Okay, a range. So maybe we could say this, and we could like have some start being a number and stop being a number. But why? Yeah. And then basically start, stop. We could indeed add also a step. The problem with the step, you have to work with some crazy stuff. But honestly, let's keep it simple. I'm gonna call this iota. This stands for, basically, I took this name from C++ iota range. So C++ also have some form of iterators, some lazy iterators. They're called ranges. But basically, this iota essentially keeps on giving you the next number from a start point. It's much simpler than a range. But yeah, so I think that's what I'm gonna call it for now. And basically, start is equal to start or 0. And let's see what the AI would do here. Let's see if that's good. Local current equal to start or 0. Local result current plus equal 1. Return result. Why put this in a variable? Just return current plus equal 1. Though of course in that case you gotta do -1. And there you go. So we're gonna start at some number, and then every time. Now the nice thing about iota, in like range and stuff, it's pretty simple. So it's more performant in some cases. Of course, depends on the case, but it's more performant, hopefully, depends. So it basically just adds a number and returns it. That's it. And it even adds just a 1. Though we could probably go with a step 2 if we want to. And then step, and honestly here, let's just say start equal to start or 0 -1. Step equals step or 1. That's basically the default values. And here we could say step, fine. Yeah. The problem though with that I can see is that you need to do plus or yes, I see. So we gotta say minus step actually here. Yeah. Is that good? Yeah, I see. So let's just shadow that variable. Can we do that? No, we can. Well, I mean, we can, but it's complaining. Okay. That's annoying. Well, let's call this S. What can I say? Right, and then here start. That's annoying. Anyways, fine. Just go with step. And then here or honestly, to be honest, let's just keep it like this, fine. So you gotta be explicit about it anyways. And let's just say, to keep things very simple, I think, turn start I don't know. Anyways, keep it like that, fine. And let's just go with that, I think. Yep, okay, fine. Now what if we do, now this actually wouldn't, I mean, it would work, but you don't really want that, because this actually is an infinite iterator essentially. It would keep on giving you new numbers. There is no stopping condition essentially. and it's going to give you an iterator of a number. And the thing is, so we could say iota, right? 0, 1. And then here, basically, we could say this, fine. Now, as you can see, it keeps on giving me new numbers, right? Though, of course, you don't want to do it this way, because if you do it this way, it's going to keep on going infinitely. There you go. So, since the iterators are lazy, you could actually express infinite sequences, you know, of numbers, which is pretty cool. And so that means that it's bad to say something like this to try to collect, because you're gonna run out of memory. Yeah, and it's gonna take forever, and you're gonna run out of memory eventually, and you're just gonna crash. So yeah, so what you need to do then, you need an adapter, an iterator adapter called take. Let's see if the AI is good at this. Iterator item, great, count number. Iterator item, items count. Okay. Well, not necessarily. It could be, yeah, it could be either the self-size hint if we have it, like the minimum between the self-size hint and the count, essentially, yeah. So I think honestly what I'm gonna do here, we'll see about that later on. Anyways, return iterator new function if items count greater than 0, then items count minus equal 1. Return self.next, and here it's actually complaining for some reason. Yeah, I don't know why it decided to add an int there. This is super weird. Oh, I see. It's I see. So here, basically, just gonna return nil, I think. Yep. Or is it? If iterator count greater than. Honestly, I like it to do it this way actually instead. If items count is equal to 0, then return nil. Items count minus equal 1, then return self.next. Essentially. Now here the hint would be count, but it would also be this, I think. Or like we could say, yeah, let's remove this. If self.size hint, then we got the minimum and the maximum. Then here, the items count would be equal to max or min. But of course it depends if that is less than or greater than. Okay, so this is the hint, I guess. Or we could essentially say this, you know. We could say this, items count is equal to math.minimum max or min items count. So the minimum of the two. Actually, is it the minimum or the max? Yeah, the minimum. Yeah, the minimum. because the iterator would basically stop either if the iterator that we're iterating through have stopped, or if the count is not enough, if the count reaches 0. So I think that's gonna be it. Well, let's try it out. I think let's try it out. Now if we say take, well, I'd like to call it this way, take 100, let's say, and let's just say for okay, let's see. As you can see, you have actually printed from 1 to 100. Yeah, correct. From 1 to 100. So that's basically 100 items. If we say one item, then it's gonna print one item, of course. And yeah, there you go. Cool. So that's a take. Now I'd like to see if it's doing the size hint correctly or not. Hold on a second. Yo, what I'm doing, hold on. Return count. Yo. Well, this should be this. But to be honest, we probably can just say this instead. Well, we don't need this anymore. I think that's it. So let's print iter size hint, and let's print it here too. Let's just remove this I here because it's fine, keep it. Oops, what I've done. So basically at first, at the start of the iterator, we have 1 size hint, which is correct, and 0 in the second, which is also correct. If we say, of course, let's say 3, then it's going to be 3, 2, yes, print I here. Yeah, 3, 2, 1, then 0, essentially. Yep, pretty cool stuff. Pretty cool. So now, the nice thing about this is that if you say, I don't know, 10,000, and then you collect this, it's going to actually go ahead, since it knows that take, the size hint of take would be this number, so to go ahead and essentially the collect function here would take the size hint of this and it would return this. So then the collect would actually allocate this table beforehand, which is pretty efficient. So if you print this, oh well, that's a big table. Yeah, that's gonna be a big table. But it's not printing it, I see. So just gotta basically loop through it if you wanna go through it. So for value in, there you go. And as you can see, that works. Right now we're actually printing the values of a table. And here, let's just make sure one little thing. I'm kind of paranoid about this. But if you print capacity, we should have that. Oops. Let's just say allocated collect. Let's say collect allocated capacity items. There you go, collect allocated 10 items, and then it keeps on inserting them in. So that's pretty cool. That's pretty cool. Great. So let's go to the next ones. So, all right. And yeah, let's see. So now we have take. Let's implement the other ones. So here it's saying skip. Let's go first with iterator.map. Let's see if the AI would do this good. Ooh, that's pretty interesting. Self.sizeHint. Cool. Cool. I love this. So it basically just reused the size hint of the great. So here it's returning an iterator new. Of course we have item and new item. So that's good because we're basically mapping from one type to another. It could be the same, but not necessarily. So self iterator item, and here we have a mapper. It takes an item and then it gives back a new item. Iterator new item. And then here return new item, local item equals self.next. If item equal nil, then return nil. Great. Otherwise return the mapper. Nice. Cool. So I think that's correct. So what we could use this for? Well, for example, here we have take. Well, let me just put this in its own line. Right? And let's say, so here, basically this code, what? Oh yeah, I see. Great. So as you can see, this iterator right now gives us from 1 to 10. But let's say we want to double each item in the iterator. How are we going to do that? Oh, we can map it. And here we can make some function, which return, oops, what I've done here. This is super weird. Value, return value times 2. So here what I've done is I mapped each item into itself times 2. So I double every item. So look at this. From 1 to 10. Now let's see. As you can see right now, it's from 2 to 20. Though of course I could even say something like, let's say we want to map it to if it's even or odd. So we could do something like this. And there you go, false, true, false, true, false, true, which is correct. And this is where the new type comes in, since the type here is basically number, but then when we map it, the new item type or the generic type, it became a Boolean value. And in fact, if we see it here, you can see that it's actually have inferred it to be a Boolean. So it returns a Boolean items or Boolean items, which is pretty cool. Now let's go to the next one. Function filter. Okay, let's see if this one is good. All right, and size hint, it would be the same because we're just mapping one thing to another. Of course, it's the size hint wouldn't really change there, so that's great. The filter here, we got an iterator, predicate here, iterator item, local item, repeat. No, this is not great. Kind of fine, but we could do it better. So basically we're just going to loop through. You're going to say for item, yeah, exactly. So for item itself dot next, right? So, and if predicate, then we're basically going to return the item since we found an item. So we're just going to return it. So essentially we are going to keep on iterating the iterator until we find some item that satisfies the predicate. That basically when we give it that item, it gives us back true. Okay. So if predicate item, then return item. Great. Okay, and here let's just return nil otherwise. So if we iterated through the whole iterator and we didn't find anything, then well, we're just gonna return nil. Now here the size hint is interesting. I'm not sure if the same size hint is correct here. The thing is about filter, once you used it, you don't really know any. Actually, yeah, that's problematic. No, since when you use the filter, if you knew the thing exactly, you don't know it anymore, because like it could be from 0 items up to the maximum, which, yeah, so no, this is not correct. So you're gonna create a new function size hint. Oopsies. What's happening here? Yeah, okay, great. So we got this. Now what it's gonna say, return self.size hint or something. No, that's bad. Okay, so let's see, hint, size hint, and self.size hint. So what happens if we don't have the size hint? Well, for the minimum we gotta say 0, I think, and for the maximum we don't know. No. Now if we know the size hint, what we're gonna do? So then we do have the minimum and the maximum. The maximum is good, yeah, it's gonna stay the same, but the minimum, no, the minimum will stay as 0. So yeah, the minimum would stay as 0. So we're just gonna discard that minimum. The maximum, because the minimum would always be 0, because we don't know how much items would be there. Unless if we iterate it through the filter, and at that point the size hint becomes meaningless. So yeah, local discard. Great. Can we do this? Of course not. Okay. All right, so that's basically it, I believe, for that one. But here, of course, we gotta return, at the end of the day, we're gonna return min max. Great. Great. So now what we could use this for. Now, instead of map, let's say filter. Okay. And watch out what's gonna happen here. Yeah, so we started from 0 to 10, right? But now we're getting only the even values. Why? Because, well, we're making a filter and we're only accepting the value if it's even. So, and that's essentially how it goes. Though, of course, you could see that this looks horrible like this. So what we could do, local function, oopsies, is even, and we could pass this here. There you go. So filter is even. So iota from 0, step in by 1, take 10, and filter is even. So that's basically the same thing. So that's great. Anyways, what about collect? Let's see what happens if we say collect. So as you can see, it's collected 10 items because we don't really know how much items would be there at the minimum. It could be either from 0 up to the maximum. So we just allocate the maximum anyways, because that's basically the worst case. So anyways, function What next? What's next? Though honestly, hold on a second. Yeah, fine. Anyways, so now what? Iterator.chain. Well, that's interesting, but not now. Let's go with instead. So we have map, we have filter. Next step, we need fold. That's weird. Out of the gate. Yeah, that's bad. So it's saying that the accumulator could have its own thing. Actually, that's good. Yeah, that's great, I think. I like trying to make sense of it though. So yeah, I guess maybe. Yeah, I think it makes sense. What about here in Rust? If we go to, what is it called? Fold. Yeah, I have a BF. But F is like the combinator. And B. And F is actually takes B and self item. Yeah, that's correct actually, I think. That's correct. Anyways, fine. Who cares? Seems good to me. So yeah, pretty much. Folder, turn accumulator. So we basically start with the initial value in the accumulator. Right? And then we go through all the items in the iterator. And we basically accumulate it with folder here. Now let's create a reduce. Okay, reduce. There you go. Yeah, great. Nice. That's correct. Here the item would basically be, it could be nil. Why? Because the iterator could be empty, and in that case, when it comes to reduce, since we don't have an initial value, it's just going to return nil at that point. So local accumulator item, for item in self.next, if accumulator equal to nil, then accumulator equal item. What are you talking about? Accumulator equal to nil. I don't think that's good. Well, basically what you gotta actually do is reducer. No, you gotta go with self.next, correct? Yeah, we're gonna get the first item from the iterator. Now the thing is, if accumulator is nil, then we're gonna return nil, right? Now we're gonna go through the iterator essentially, and we're just gonna use this guy. So the remaining items in the iterator, we're just gonna go through it and use the reducer with it essentially. And I think that's good enough. Yeah, and here notice that folder is more, or fold is more, basically, what can I say? Or actually we could indeed express fold in the same manner as, like, could express reduce in fold. So you could indeed do this instead. If we ignore the performance, we could say this, turn self fold. Reducer self.next. Yeah. Now if initial is equal to nil, then yeah, honestly, let's keep it that way. I don't care about performance, to be honest, at least not that much for now, at least. So that's much more readable. So this is basically the difference between fold and reduce. So if initial is equal to nil, so basically the initial value would be the first item in the iterator. If it doesn't exist, then we're going to return nil if that item doesn't exist. And there you go, done. Done. Yeah, I think that's good now. Great. What's next? Nice. So we have for each. Is there another kind of interesting thing? Yeah, there's find, for example. There is find. But fine, let's create that for each. For each. What do you mean by action void? Void in Luau is like this. Basically, there you go. So self and iterator item action. Okay. For item in cell.next action item. Correct, yeah. Correct. So now basically what we could do, let's say we want to, I don't know, let's print, okay, iota, take 10, maybe let's map it. Let's just try to use all of them possibly. Map double take 10, and then instead of collect, let's just say reduce, add, exactly. Now let's just, hold on, iterator.iota. And what's happening? Anyways, function double. Oops, what? Well, basically you take a number and you return the double of that. And finally add. There you go. So right here we say in iota, we're mapping that double. So basically we're doubling every item there, then we're taking 10 of them, and then we're reducing them using add. This is basically sum. And there you go, the sum is 110. Though you gotta be careful, of course order matters. So for example, take 10 here. Do you want to take 10 of all the doubled? Well, actually it doesn't matter in this case. What does it? Yeah, it doesn't matter since we have map. But it would be different, I think, if it was filter. Yeah, or it doesn't matter in this case. But if it was filter, for example, then of course it would matter. But anyways, so that's pretty cool. And instead of actually this, we could also say, could say for each print. Just like that. So that's pretty cool. So for every item we're gonna print it, and there you go, 220. That's pretty cool. Map for each. So there you go, looking pretty interesting. Nice. So what's next? We could go with the sum. It's pretty simple. Pretty simple. It's basically function a b return a plus b or 0. So if there's no items in the iterator, we're gonna return 0. Here we're just gonna get, I think, number, b number, and you're gonna return a number, and that's basically it. Yeah. So now instead of, oh yeah, I removed that. But basically instead of let's say reduce add, you could just say sum. And this also handles the but like this one doesn't handle when the table is empty. When it's empty, it's gonna give you nil, which is not exactly sum, but this is sum, right? But yeah, we could just say this sum like that, and that's good. So yeah, what else? Though I'd like to make it generic into any kind of t, but the problem, it's gonna not accept it. So yeah, but anyways, so that's basically it for sum. Let's go with product. There you go, great, and let's go. Nice. Now honestly I don't wanna, yeah, let's just say add, and well, what I'm doing, multiply, yeah. So here is add, here is multiply, or 1. This is the identity, the multiplication, the multiplicative identity, yeah. So yep. Oopsies. Being mathematical here. That's pretty cool. Anyways, that's basically it for sum and product. What else? We could even implement max, min, blah blah blah. And honestly, I feel like that should probably be in its own kind of module. Yeah, let's just keep the bare bones here for now. Let's just remove sum and product. We're gonna maybe make it in its own module where you have all sorts of crazy mathematical stuff. So yeah, that's pretty much it, I think. So now let's create the other stuff. Is the stream still fine? Seems good to me. Yeah, okay. Great. So what's next? So let's implement function. These are basically the iterators that actually kind of like consume. I'm not sure if there's some technical word for it, but let's just say iterator consumers. Hold on, those functions, or those functions that transforms iterators into scalar have a name. Well, I know it's reduce or fold, but not really what I meant. No. Hold on. Does iterators that consumes, or like does functions that consume iterators and return a value? Have a name? Iterator consumers, or simply consumers. Yeah, exactly. This function take an iterator and process elements, produce a result. Great. So yeah, let's just call it iterator consumers. Fine. Great. So these are the iterator consumers. All of these can actually consume the thing. We could also create some iterator.drain. And this basically does nothing. It just drains the iterator, though. Like, I don't know why you would want that. But there you go. It just drains the iterator, it consumes it, and that's... I mean, it could be useful for something that actually has some side effect. But anyways. There you go. In Rust, we do have that. So that's cool. Where is this drain function? Are you kidding me? Yeah, I couldn't find it. Rust drain iterator, or drain function, or whatever. Yeah, it's in std_vec. I see. v.drain, as you can see. Though you give it some range. Removes the specified range from the vector in bulk. Well, anyways, fine. Whatever. So what's next? Yeah, we could also implement any. So this basically, if for items held on X, if predicate item, then return true. Great. Otherwise, return false. That's cool. This is basically short circuiting. If we find some true, hold on, which? Not exactly though what I want, or at least not what I thought about. Hold on. Yeah, that's fine. That's fine. I think return and true. Oopsies. Okay. What about all? If not predicate item, then return false. End. Great. Great. And that's basically it. Now what you could use that for, basically, let's say you have some iterator dot iota, whatever, and you basically want to see if all of them or any of them, like let's say are they even or not. Like let's say if all of them, honestly we gotta make sure to say take 10 for the 10 values, all function value yes, return. So this would basically give you a boolean false. Why? Because not all of these items are even. If we say any though, of course it would work. So we're gonna say true. Though if we filter though, if we filter this to be only the odd values, hold on a second. if you filter this to be the only odd values, let's say equal to 1 here, it's going to say false because there's no any value in this iterator anymore because we're filtering only the odd ones. So basically, but anyways, if we say the all and here say even, but yeah, you got the point. You got the point. Whichever. So what's next? What's next? So let's go. Iterator all. I should write some tests for this honestly instead of just doing it this way, but anyway, for now it's fine. What's next? Yeah, we need a find. We need a find too. So we got the iterator, predicate, item. For item in self next, if predicate item, then return item great, otherwise return null. That's cool. That's pretty cool. So this would basically go ahead through the iterator and tries to find an item. If it can find it, or it can, yeah, it's just gonna return that item. And there you go. What's next? What's next? We can also implement, find index. That's cool. By the way, we could also do this using filter if you want to. Anyways, find index. Local index equal to 0. Predicate. It does have, yeah, in Rust it's called position. And it basically returns the index of that item that it found. Then return index end essentially. But this would start from 0. Yeah, it would start from the index 0. Do we want to start from index 0 or 1? Probably you want to do it with 1. Because lower tables unfortunately start with 1. So yeah, count, yeah, that's good. If predicate, then predicate. Ah, yes, I see. So what I was thinking is that it would just count all the iterator items and that's it. But nah, here it actually also includes the predicate. Though we could indeed make this I mean, in Rust, count actually doesn't have a predicate. It just counts the iterator. That's it. Maybe there's some other kind of variation of count that does that uses a predicate. But honestly, no, I don't like this. I mean, you could just use filter then count if you want this kind of behavior. So what am I gonna do? Honestly, I'm just gonna count plus equal to 1 and that's it. Count. As simple as that. That's the count function. So basically, if you have, like, you could print some iterator.yacht take. This would just give you the count. Attempt to call a nil value. Ooh. Yep, there you go, 20. Because we're taking 20 items there. So that's cool. What else? Max. No, let's go with the... It's some other one. Let's go with zip, I think. Let's go with zip. Maybe function. Iterator.zip. Here you're gonna have item A and item B. Yeah, fine. Let's see what the AI would do here. Yeah, item A, item B. Let's see if this is correct or no. I don't know, I want to avoid this, but the problem with that, yeah, it's not gonna work that way with the tuple. You gotta make it a table. Yes, so, which is unfortunate. Well, unless maybe if Luau is kind of optimizing it away somehow. Anyways, type item could not be converted to item A. Item B, return. But the problem is in Luau I cannot really do it this way. Yeah. If I want to do this, actually what I gotta do is item B like this, I think. Expect one type argument but none are specified. Huh. Yeah, zip doesn't really work with the type check and stuff. As you can see. So I'm not sure. Actually, yeah, let's just say maybe item A and then, but no, that doesn't make sense. It would basically be, hold on, I'm kind of confused right now. What even zip does? I mean, I know, but and just single iterator. Yeah, pairs. Essentially, yeah, but like you cannot really do it here using the type checking. So why it doesn't allow me to do it this way? I don't get it. I mean, this makes total sense. But none are specified. Okay. Yeah, it just doesn't work that way. But maybe we could do it this way instead. Like maybe we could say either. Not really not what I expected. Let's say pair actually. Let's say pair. But this doesn't work. So, but what if we say first and second? Just like C++. Yeah, that seems to work out, I guess. And we can even export this type, really. But basically here, pair, well, iterator, pair item AI. And yeah, that seems to be working out at least. So, okay, not the best, but yeah, fine. Because like basically if you want to support multiple return items in iterators, it's gonna be rough, and it's also not gonna be very good for performance. It's just super bad to return multiple items, because then you just basically have to kind of like pack and unpack stuff, which really is a nightmare. Like not good. Not for performance, not for readability, not for anything. Anyways, just gonna make a mess. So, okay. So here, let's just say first, oopsies, first item A, item B. Well, we could say first item, fine, and second item. Okay, cool. Great. First item, second item. Oopsies, what happened? Where I am. There you go. Not sure why it's teleported there. Anyways, I think right now it's good. So let me just try to make the AI does it again or do it again. Let's see if it can do that. Yeah, it seems to be good. First, second. So other. Hold on. Iterator.new. If first equal nil, then return nil. Yeah, that's good. Actually, that's good. Local min max. Okay, so this is the size hint. Well, that's interesting. I'm not sure. Minimum max 0 nil. It's basically gonna be, well, I'm not sure exactly about the semantics of a zip function. There you go. If either iterator returns none, next from the zip iterator return none. So if either of them would return none, then we're just gonna stop the iterator there. Okay. All right. Well, if first equal to nil, then return that. And if second is equal to nil, then return that. Okay. Otherwise, if we got them both, then return both. Essentially. So, yeah. So now if we say this, unfortunately we don't have pattern matching in Luau. Well, that's sad. Anyways, pair in iterator dot, let's say we have some table, okay? Fine. And let's say we got iterator dot the keys, let's say keys t, and then the zip with iterate what I'm saying t, or actually iterator dot values t, exactly. Oops. Bro, this is super annoying. Nope. Okay, let's see. All right, that's super useful. Let's say first and pair second. And let's see. And there you go. Great. So zip is working. Now what about in zip? Well, for in zip, I think it basically unzips it into two collections. Is that correct? I think so. Yeah, basically. Containers, yeah. Well, can we do it in any other way though? In zip. Well, let's see. The AI seems to like chain function. In zip. First item. Second item, self iterator, second item. It seems to give two iterators. Cool, but okay, pair equal to nil, then return nil, return pair dot first. That's super bad. What it's doing? No, that's not how it works. Yeah, no. Yeah, that's not gonna work out. Because you cannot advance the first and second iterator separately or independently, unless if you collect them into a collection. So this is super bad. No. Okay, so let's say it's just gonna basically get an first item and second item. Yeah, pretty much. And let's see if the AI can do this now. Right, remove this. So for every pair in self.next, do table.insert first pair.first and second pair.second and return first, second. Great. All right, now, can we actually optimize this a bit further? Using table.create. Didn't seem to catch up with me. But anyways, so what I'm gonna say, hold on, did I really check this out? No, I didn't. Yeah, I didn't really make sure that zip. So it's saying min max if self and other dot size hint. I mean, okay, local min max 1, min 2 max 2, skin both. Now minimum is math.minimum, and it's getting the minimum here. So either max 1 or min 1 and max 2 or min 2. But what happens if you have only one size hint? Because basically if you do, interesting. So type error type number could not be converted into number. But is that correct? Max min. Yeah, it's super weird, this max min stuff. Alright. So basically, yeah, let's think at once, like the first, like minimum first. So for the minimum, for zip, so if we have the size hint of dots, it's gonna be the minimum, max. I have no clue. But this should be, hold on, number this. Okay. Minimum, maximum. Okay. Otherwise, you don't have any of them. So at that point, minimum could be 0 and maximum nil. We don't have any idea what's going to happen essentially. It's not a big deal though. It's not a big deal to get it right, but it's better to get it right. Anyways, so here we got the capacity actually. Local capacity equals 0. capacity equal to max or min. Yeah, that's cool. Second, same thing with that. Table of create, table of insert, pair, table of create capacity. Yeah, that's good. That seems good to me. So let's try this out, I guess. So this works, right? Yeah. But if you say in zip, then well, at that point you're gonna get two things. You're gonna get back the keys and the values essentially. So come on. Okay. Let's say keys for each branch and values for each branch. What? Ah, yes. This is not an iterator. This is a table. So sad. Okay. For Ivy, there's keys. You gotta create a table library. Anyways, value in keys do. I mean, we could indeed go ahead and do this if we really want to. We could say iterator dot. What was it again? U. No? No. Yeah, it was values, right? Keys. And then we could say for each branch. Not the most efficient, but who cares? There you go. So let's print these, and there you go. A, B, C, 1, 2, 3. Hold on, 1, 3, 2. Ah, yes, because it's a hash map kind of thing. Yeah, there you go. So that works. And zip works. Great. Great. We could probably generalize it, but it's gonna take a hit in performance because we're gonna allocate a table to hold all the results and stuff. And I mean, actually, we're already doing it. But then you're gonna, I guess, lose. Yeah, you're gonna lose out on type checking though, because yeah, pretty much makes sense. Now, the nice thing about this, it doesn't really give me the type though. What if I say some local x equal keys? Oops. Can it infer the type? Why it's giving me only a? Weird. It should be able to infer the type from all that type checking, but it's just telling me B, A. That's stupid. Anyways, it really needs a lot of work, I guess. Anyways. Whichever. So what's next? Well, this is a consumer of the iterators actually. Yeah. And this one, it's an adapter. So this one is a consumer, just in some sense. Bro, that's a lot. Okay, cool. Right, so these are the consumers, zip. Let's actually put this type here. And these are the constructors. This is just a helper function. Bruh, come on, I lost my copy. There you go. Get table size. So keys, values, iota. Okay, so here we're starting at not transformers, it's called adapters. What? I mean, in some sort they are transformers, but anyways. Iterator adapters, there you go. So it basically takes an iterator and gives you back another iterator essentially. So yeah. You're in map, filter, fold, zip. Okay, what's next? Enumerate, yeah, for sure. Enumerate. You don't really need all this stupid stuff, I think. Let's just say return iterator dot zip. No, self zip. No, zip with iterator iota. Exactly. But actually, I want this to be first. I think. Yeah, I want that to be first. Then zip self, I think. Yep. So the first would be the index and the second would be, yeah, that's cool. So turn iota zip number item. Great. What's next? Okay. Oh, chunk. Well, that's gonna be crazy. No, honestly, to not have to deal a lot with this size hint stuff, if I can, I'll try as much as possible to reuse old functions. Hold on a second. Fold is actually, yeah, fold is not an adapter though. Fold is a consumer basically. Great. So adapters are quite tricky when it comes to size hints. Map is pretty easy in terms of size hints. It's just the same thing. Take, it's the minimum between them. But yeah, it's crazy stuff. All right, so what's next? Did I miss anything? Let's see. Chunk. Is there anything else? That was pretty complex. Chain, yeah, that chain would be interesting. Chain and step, also step would be interesting too. Cycle, yeah, there's just a lot. There's a lot. So, well, function iterator dot step. Let's see. Yeah, the AI doesn't know how to do that, I guess. Let's see. Super duper slow. It should be pretty simple, I think, no? Yeah, should be pretty simple. But yeah, I just couldn't figure it out. Fine. Okay, there you go. Item, let's see. For one step. What? Local item equals cell dot next? No, that's super bad. I don't think that's how you do it, no? 1 comma step. That doesn't make any stupid sense, no. Yeah, no. Okay, so that's bad. So basically what you gotta do is, but hold on, what step even means? Essentially we're gonna skip some items. Actually, that's correct. Yeah. Yeah, that's actually correct. My bad. My bad. Yeah, that's correct. And then local min max 0 nil self size hint, then discard max size hint. Fortunately, even if I got the size hint function wrong, it should be fine. It's just that it's not gonna be well, not totally fine though. Yeah, because we may actually allocate a big table or something like that. Anyways, local min max 0 nil cell size hint discard max. Actually, that's not correct. Basically, if we got the self size hint, then what's gonna happen is max divided equals step. Yeah. Max divide. But if we find max though, yeah, if we find max y minus equal, that's stupid, divided by, and an integer divide though. But honestly, would it really do the job? I don't know. Let's see. Luau, let's say we got some maximum of 10 and step of 2, then it should be fine. But if it's 3, if you say this, it's gonna tell you 3. Well, is that correct? Let's keep it simple. Let's say 3. But if you say 2, it's gonna say 1. Yeah, I'm kind of confused right now. So we're skipping 2. Okay. And yeah, that's actually correct, I think. I don't know. It's weird. But I think it's correct though. Anyways, fine. So basically what you could use that for is essentially to do something like, let's remove this stuff. Let's say iterator.iota 0 1 dot, or not dot, yeah, let's say this for example, and this is what you get. But if we say step 2, huh? What does that even mean? Step 1, actually that doesn't work out. Way. Item, then return nil and return cell.next. That doesn't make much sense. I'm missing something here. But why it needed that? 'cause, I mean, it should be fine. I mean, in this case, I think it's correct. Yeah, it's correct. We're stepping by one, essentially. But what I don't understand is why this doesn't work. That's weird. Okay, what if we even don't do this? What? Actually, it works now. So what was wrong? Yeah, there you go. It actually works that way. So is take maybe wrong or something? I mean, it seems to me. That's weird. Take. Yeah, size hints honestly is overcomplicating things. Anyways, if count equals 0, then return nil and count minus equal 1. Return so. I don't really see a problem with that. Yeah, no clue what is wrong. Oh well, let's just continue. Okay, what else? What else we could do? Function iterator zip, enumerate step. Well, honestly, instead of step, maybe we should call this step by, because that's exactly what it is. Let's just remove this for now. Not sure what was the problem there, but anyways. Chunk. Yeah, chunk is crazy. Okay. I think honestly we have already done most of the advanced by. Like, what is the difference between step by and advanced by? Ah, the nth element. The nth element would be interesting. Yeah, honestly, instead of step by, let's start with something pretty simple. Let's start with skip. Now for skip, we have count iterator item. For count do cell.next equal nil, then return nil and yeah, we're basically skipping those items. Then okay, return cell.next. Yes, okay. So it's lazy. Oh. Super confused now. This should be eager, I think. Not Charlie. Yeah, I probably have to take a break at this point. Yeah, my brain is blocked. Yeah, anyways, let's just right now what we're gonna do other than that, I'm just gonna create some other module, Luau, and this would just contain some functions. I just called it lambda because I don't know what to call it other than that. So anyways, so now what we're gonna do is we're gonna have, not really, this would basically just contain some simple functions like add, etc. Or honestly, maybe we could even just say this. Yeah, pretty much that's fine. Sub, mol, div. There's just gonna be a collection of functions. That's basically as simple as that. Pow. Unim length. Concat. Ooh, I forgot even that Luau have a concat function. EQ. LTLE. Yeah, basically just translating all the built-in operators into functions. New index. New index. No. Don't think that's good. Or is it? Nah, let's just remove that for now. In fact, yeah, concat EQ. Honestly, never mind. Anyways, at this point, I'm just gonna stop the stream. I've been streaming for 2 hours. Okay, so I'm gonna actually publish this to my GitHub account, and I'm gonna send the link in the comment section. You're gonna find it when I publish it, and also in Discord, basically. And so yeah, that was it for this stream, and see you later. Goodbye.